Imagine a universe whispering ancient secrets, where each star and cell dances to an unseen rhythm. And what if everything we see, the life, the cosmos, the very beat of our thoughts, was not just a coincidence, but part of a greater design? Today, we'll embark on an exciting journey from the brain's core to the edges of reality. It's a story of science, mystery, and possibility that leads to an extraordinary question. Could there be an intelligent design behind all of this? But before we set off on this fascinating journey, as we always do, we invite you to subscribe to the channel to support our work and to not miss any new videos. The idea of intelligent design behind the universe and life has long been debated by scientists and philosophers. Usually, this concept clashes with what Darwin said. Life is so complex because it is made up of random processes and natural selection. But there is something interesting that is changing the game. A 2005 study called Long-Term Modulation of Electrical Synapses in the Mammalian Thalamus by Landesman and Connors, published in Science, takes us inside the brain with a fascinating discovery. It doesn't directly demonstrate an intentional order, but it shows us a complexity that invites us to reflect. Could there be something more than mere chance behind all this? This study takes us into the thalamus, a key area of the mammalian brain, for a closer look. What are electrical synapses? Special connections between neurons that allow electrical signals to pass in a flash in both directions, unlike chemical synapses, which are slower with their messengers. And here's something curious. These synapses don't stay fixed, but adjust over time. They can adapt by changing in response to what happens in the brain. It's a discovery that has shown us, that makes us see how complex and alive the nervous system is. So much so that, as we will see, it makes us wonder if all this could really be just a coincidence. From this, we might ask, what if the universe and life were planned, not just luck? A design that can be seen in the laws of physics, in biological structures, and in super precise mechanisms. But let's dig deeper into the thalamus. Electrical synapses are everywhere among inhibitory neurons, the ones that pause certain brain activities, and they're not rigid. They change, they adjust, showing a surprising plasticity. This tells us that the brain is not a fixed box of connections, but a living network that adapts and responds. Such refined complexity makes us marvel, but it could just be a coincidence. This plasticity, along with that of chemical synapses, helps us better understand how the brain handles complex information, coordinates responses, and maintains balance, even as our environment changes. This complexity pushes us to look further, all the way to the origins of the universe. Modern cosmology shows us something extraordinary. The fundamental rules of the cosmos, the force of gravity, Planck's constant, and the speed of light are calibrated with impressive precision. What if these numbers changed even just a little bit? No stars, no planets, no molecules for life. That's what scientists call the fine-tuning of the universe. And if we combine that with what we see in the brain, like the plasticity of synapses, in the study by Landesman and Connors, it opens up a scenario that makes you wonder, what if there was a connection between these levels of order? The universe now appears as a well-ordered system with laws and mechanisms seemingly designed to create and support life, rather than as meaningless chaos. Returning to electrical synapses, consider this. What if they function like a biological code? Not just a piece of the puzzle, but a set of instructions that allows life to exist, to adapt, to learn, and even to look in the mirror and ask itself who it is. So they change over time. Long-term modulation isn't something separate. It's part of a nervous system that takes in signals, processes them, and produces behaviors that work. It's a level of connection that suggests a hidden architecture, a design that's more than just the sum of its parts. And if we broaden our view to the evolution of life and the birth of the universe, we can imagine that intelligent design isn't someone coming in and arranging everything from above. Maybe it's something more subtle, a principle that lives within the laws of nature, written there from the very beginning. This leads directly to the core of Landisman and his team's research. There we find electrical synapses, a system in the brain that is as mysterious as it is astonishing. Until recently, we didn't fully understand them, but now they're revealing something special. Unlike chemical synapses, which send slow messages using chemicals across a gap between neurons, these work in a direct way. They use small channels called gap junctions, which connect two neurons as if they were a single unit. This way, electrical signals pass quickly, almost instantly, creating perfect synchrony between the cells, which can communicate with each other in both directions. And there's more. One of the things that stands out in the study is the ability of electrical synapses to change over time, a phenomenon called synaptic plasticity. We usually associate plasticity with chemical synapses, where long-term changes help the brain learn and remember. It seemed less relevant for electrical ones, but Landisman and Connors found that in the thalamus these connections adapt, responding flexibly to surrounding activity. This could be proof that the brain is not just a transmitter of signals, but actively adapts as if it were responding to the outside world. This reveals how adaptable our nervous system is, highlighting a complexity beyond simple information transmission. It almost seems like an engineer's work. Every part is calibrated to work with the others, keeping everything in balance. If it were just the result of random mutations, we would expect some errors or waste. Instead, here and there, it's as if everything is tuned to work at its best. Another sign that might make us think of intelligent design, but let's try to look at it from another point of view. Think about artificial neural networks, the ones we use for artificial intelligence. They are man-made systems, inspired by the brain and designed for a specific purpose. Processing data quickly and efficiently, with connections that adjust as they learn. The electrical synapses in Landisman's study are incredibly similar. They change, adapt to stimuli, and respond dynamically. The difference, however, is that we created artificial networks with a clear plan in mind, while these synapses were born in nature. Without a designer, we can see. This raises an interesting question. What if nature was inspired by a design idea? Or maybe if the design was already within it? The precision with which these synapses synchronize neurons, almost like a mathematical calculation, makes you think they are part of something bigger, guided by rules that go beyond chance. Linking this to our earlier discussion about the universe and biological code, each piece seems to reveal more of a hidden design. Going back to what we were saying about electrical synapses, there's another aspect of Landisman's study that's worth exploring: the way these connections keep everything in sync in the thalamus. This synchrony is fundamental. Consider how we perceive sounds or images, or how the brain shifts from sleep to being awake. Electrical synapses aren't just sitting there watching. They change over time, regulating how much neurons communicate with each other and adapting to what's needed at that moment. It doesn't happen by chance. It requires a precise interplay of molecules, electrical signals, and structures working together for a meaningful result. In biology, synchrony is often described as a spontaneous phenomenon. But when you see it everywhere, from the rhythms of day and night to brain waves, you start to wonder if there's a deeper order, something that seems intentional. Now let's shift from the brain to the universe, where we find another signal relating to our earlier point about fine-tuning. The basic rules of the cosmos, the force of gravity, the electromagnetic constant, the mass of the smallest particles, are calibrated with a precision that leaves you speechless. Try to imagine if gravity were a little stronger, the universe would have collapsed in on itself right after the Big Bang. If it were weaker, no stars or galaxies, nothing at all. It's a narrow window, a perfect balance enabling life to exist. Scientists call it a mystery of the cosmos. Some think it's just luck, or maybe that there's a multiverse out there with infinite possibilities, but there's another possibility, that this precision isn't random, but part of a design that prepared the universe to host complex things. Like the electrical synapses we're studying, Those same synapses, with their ability to adapt, seem to have come from a universe that somehow knows how to nurture life. This leads us to a more interesting point. The physical laws don't just make organic molecules possible, they organize them into living systems. Let's go back to electrical synapses. They work thanks to special proteins, like connexins, which fit together to form those gap junctions we were talking about. This only occurs because the chemical and physical conditions are perfect and rely on the universe's constants. If the cosmos weren't so stable, these structures wouldn't exist. It's as if the order we see in the brain is an extension of the order of the stars, a continuous line that goes from the birth of the universe to consciousness. That makes us think and talk about all this. But let's step back since there's a related question here. Darwin described evolution as random mutations combined with natural selection, lacking a specific direction. Looking at Landisman and Connors' study on electrical synapses, we see plasticity that enables the brain to adapt. It makes you wonder, what if it's not also random? Maybe there's something in the laws of nature that guides biological systems toward ever greater complexity. In this idea, intelligent design doesn't fight evolution, but transforms it into something intentional, where mutations and selection aren't completely random, but follow a predetermined path. Electrical synapses, with their synchrony and flexibility, could show us that nature has a program to create increasingly useful and functional structures. And how does this program work? Think of nature's laws as tracks, shaped by universal chemical rules. These laws aren't arbitrary. They determine what can occur and which mutations are successful and adaptable. Maybe intelligent design is exactly this, a plan that lays down these rules, creating an environment where evolution isn't blind, but explores possibilities that are already prepared. The plasticity of synapses doesn't seem like a coincidence, but the result of a system that knows how to evolve towards something efficient. Continuing our discussion on laws of nature as tracks, there's another related phenomenon: evolutionary convergence. It's when different creatures that aren't related end up developing similar features because they have to face similar problems. Take eyes, for example. Octopuses and vertebrates develop them independently, or the wings of birds and insects. Evolution appears structured to drive towards specific outcomes. And what if intelligent design were a kind of silent architect, something that puts an inclination to create complexity into the laws of nature? Everything leads us to an idea that often comes up when talking about design: complexity. Irreducible is the concept that some biological systems are too complicated to have arisen one step at a time, only through small random changes. Electrical synapses don't have a sign that says irreducible, but look at them. They depend on a mix of proteins, electrical signals, and molecular controls that all have to work together. How could such an interconnected system form if all parts aren't ready from the start? One possibility is that evolution didn't work alone, but had a push, a design that put the basic pieces there, ready to be used. Here, natural selection doesn't create everything from nothing, but selects from existing possibilities due to a hidden design. But we don't have to discard everything we know about chance. The idea of intelligent design doesn't mean saying goodbye to random mutations or natural selection, but seeing them in a bigger picture. Mutations can be the fuel that keeps the engine running, and selection the filter that keeps the best. But maybe they work within a system designed to bring life to ever higher levels of complexity and awareness. Electrical synapses, with their ability to adapt and synchronize everything, are a perfect example of this balance. Perhaps they come from random events, but how they function doesn't seem accidental. It's a compromise that surpasses the old debate between evolutionists and creationists, presenting evolution as the method through which intelligent design is revealed. The universe, then, is like a living laboratory. Chance exists, but it doesn't control everything. There's an intention written in its foundations that gently guides it. The hypothesis of intelligent design finds a place of its own. In an ancient conversation between science and religion, modern science usually tries to understand the world without involving supernatural forces, while many religious traditions see the order of the cosmos as the work of a divine entity. But what we're exploring here is different, a sort of middle ground. There's no need to imagine a creator intervening from above. Rather, the idea is that intentionality is already within the laws of nature. Let's revisit Landisman's study on electrical synapses. Their plasticity and the synchrony they create seem like examples of this. It's as if they were made to support life and consciousness, a mechanism that carries a sense of design. There's no need to abandon scientific rigor. We need to open our eyes and ask if the order from the thalamus to the universe reveals something intrinsic. All this brings us to a limit that science encounters, something that connects to what we were saying about guided evolution. Science is very good at telling us how things work. But when we get to the why nature created such a refined system, the answers become more elusive. The same applies to the universe's fine-tuning. We can calculate how precise those physical constants are, but explaining why they are perfect for life is another story. Intelligent design emerges as a philosophical hypothesis to fill the gap, suggesting there may be purpose rather than everything being a lucky accident. It's not abandoning science. In fact, it encourages dialogue between disciplines and going beyond just numbers. Intelligent design challenges the way many people view the universe today. A place without purpose, guided only by physical laws that have no direction, is the so-called materialist paradigm. But when, for example, we look at the plasticity of electrical synapses, in Landisman's study we find an organization that seems too perfect to be just an accident. If everything was truly random, you'd expect more chaos and imperfections. Here and there, instead, the thalamus works with a precision that seems almost calculated. Imagine if we could prove these synapses' synchrony is the secret to consciousness. Wouldn't you wonder if the universe was built specifically to make us think and understand? And it's not just the brain. Cosmology could also help us, maybe with new clues about fine-tuning or how the first molecules of life were formed. These advances could show if design is a reliable path. Clearly, it's not a definitive answer, but a hypothesis that pushes science not to limit itself to the how of things, but to try to touch on the why as well, taking us to places we haven't explored yet. There's more, something linking to the interdisciplinary dialogue we discussed earlier. Intelligent design could become a bridge, a way to bring together different worlds. Neuroscientists, physicists, philosophers, and theologians could all collaborate to better understand topics like electrical synapses or cosmic fine-tuning. It's not about finding a truth set in stone, but about enriching what we know about the universe. We began with Landisman's thalamus study. With electrical synapses that adapt and synchronize so well, it seems they're meant to make us both adaptable and noticeable. From there, we looked at the bigger picture, the physical constants of the universe, regulated with such incredible precision that they seem to set the stage for life, an order that spans from the stars to our brain's networks. Maybe evolution isn't as blind as we think, but rather a way these laws create design. Philosophy and science intersect here, urging us to reconsider our knowledge and foster broader dialogue. Together, these pieces reveal a universe that appears intentional, designed to create and support life in all its forms. Fine-tuning, with its breathtaking perfection, creates the conditions for these structures to exist, and evolution becomes the way it explores what is possible. There's no need to imagine an external designer. Intention appears inherent in reality itself, woven into its foundations. From physics to biology, every level is linked. It's as if the universe was meant to turn chaos into increasing order, up to beings able to look within and question who they are. It's an idea that transforms our view of the cosmos, not as cold and indifferent, but as purposeful and gradually revealing itself. Intelligent design is not a ready-made answer to be framed. but an idea that deserves to be explored both with science and with philosophy. What we know puts us face to face with questions we can't ignore. Why is the universe so perfect for life? How do such complex systems come into being with so much harmony? Rather than leaving them unanswered, we can treat them as an invitation to keep searching and push beyond what we know. New discoveries about the thalamus, the origin of life, or the cosmos could give us more clues to confirm or disprove this view. At this point, we invite you to write your opinion in the comments, and if you enjoyed the video, don't forget to subscribe to the channel to support our work and to not miss new videos. See you in the next story.